Up until now, we've been looking at one variable statistics. Now we're going to take a look at two variable statistics. And the reason why we're going to explore two variable statistics is because most people are interested in the relationship between the independent variable and the dependent variable. The example that we have here is the age of the driver as the independent variable and the number of fatal accidents as the dependent variable. So what we want to look at is see what the relationship is between those two variables, and we can use a scatter plot of the data to determine whether or not there is a relationship. So let's go ahead and plot that scatter plot here. And put the driver age on first. We'll do 18, 19, 20, 21, 22, 23, 24, 25, and then we'll do the number of fatal accidents on the y-axis. So let's go up by twos instead. 2, 4, 6, 8, 10. So my first set of points are the 18-year-olds, and I've got 8, 4, and 2. Second set is 19-year-olds, 7, 7, and then 6. Third set is the 20-year-olds. I've got 1, 7, 1. Then the 21-year-olds, 6, 2, and 10. Then the 22-year-olds, 3, 10, and 4. Then the 23-year-olds is 1, 9, and 8. Then the 24-year-olds, 10, 3, and 3. And then the last one are the 25-year-olds, 10, 2, and 9, which is my scatter plot for the... Now, before I made the scatter plot, I already had an expected result, which would be my hypothesis, and I would have guessed that as driver age increases, the number of fatal accidents decreases, which would have been shown by a scatter plot that looked something like this. So the points are going down and to the right. But instead, really what I see is just a giant blob of points that are in the middle of the graph, and there's no relationship between those points. Perhaps I would have had something different if I had increased my age bracket, or if I'd looked at the age in groups, so the accidents between 18 and 25 compared to the accidents between 25 and 35, and then 35 and 45. Perhaps I would have seen a relationship here. But in between 18 and 25, it doesn't appear that there is any relationship between the driver age and the number of fatal accidents per year. So let's keep going. We're going to look at some definitions, some of which you should already be a little bit familiar with. So the first one is a scatter plot, which is a graph in which data are plotted on the x-axis and the other on the y-axis. Each point represents a pair of values. Okay. What we are working towards drawing is a line of best fit, which is the line that passes closest to the data points on a scatter plot and best represents the relationship between two variables. We also have the independent variable, which is a variable that affects the value of another variable. And usually it's graphed along the x-axis. We also have the dependent variable, which is a variable whose value depends on the independent variable. And typically, this one is usually graphed along the y-axis. Using these tools, that allows us to determine the correlation, which is the relationship between the independent and dependent variable. And the last term is an extraneous variable, and these are variables that affect the relationship between the independent and dependent variables. So in our example above, an extraneous variable could be taking driver's training. So people who took driver's training hopefully have less fatal accidents. That would be something that could impact the relationship between the two variables that we're investigating. So what a scatter plot does is help reveal a relationship by showing a general trend in the data. And here are some examples that we're going to look at. Something that can help to figure out here is by putting kind of a bubble around your data here. This one, because the data is clustered, it doesn't really show anything. This would be an example of no correlation. Okay. Moving on to the second one here. This is the same thing. There appears to be no relationship. The dots are just scattered randomly, which, as you might expect, absence from school and height, chances are slim that those are going to be correlated. Moving on to sort of example 2C here. If I draw a circle now around my cloud of points, what I can see is that as I move to the right on the graph, my points are trending downwards, but they're not that close together. So I would say they have a weak negative correlation. The next graph here, if I draw a circle around my cloud of points, what I can see is that they're clustered very closely together, and that as I move to the right, my points are decreasing. So this is a very clear trend, and this line of best fit has a strong negative correlation. Going on to my last example here, if I draw a circle around my points like this, ignoring these two as outliers, My bubble is sort of showing that my points are rising up to the right very gradually, so this would be a weak positive correlation. In terms of positive and negative, a positive correlation is if y increases as x increases, and my line of best fit, which we'll get into a little bit later, would have a positive slope. A negative correlation is that y decreases as x increases, or my line of best fit would have a negative slope. And so the last thing that I will say is that the stronger the correlation, the more closely the data clusters around the line of best fit. So before I conclude, let's go back up to these two examples here of the negative correlation. I'm going to draw on a line of best fit here in blue, approximately. So you want about the same number of points above and below your line of best fit. Okay. And so what I can see is that the points are somewhat close to my line of best fit that I've drawn here going through the points. There is a mathematical way to calculate it. For right now, we are just eyeballing it, which is fine. Now, if I use this one here and I draw a line of best fit, see, I wasn't that close on that one. Let's erase that. If I try again here, I'll see if I can do a little bit better. If I draw a line here, okay, and I'll redraw my circle, what I can see is that the points are much closer to this blue line of best fit that I've drawn, okay, which indicates a